Hello, good morning everyone. Myself Jafar Sadiq Ali, Professor, Electrical Electronics Department of Sri Muthukumar Show Technology, Chennai. In so the subject I'm handling is IoT concept applications. In this lecture series, we are now going to see in Unit 3, we are going to see the MQTT and COAP protocols. Already we have seen IPv6, 6LoWPAN. Now we are going to see MQTT, COAP, these two only. So let's move on. So what is MQTT? MQTT is nothing but message queuing telemetry transport. Expansion is message queuing telemetry transport. It is a lightweight message protocol designed for low bandwidth, low power, and unreliable network, mainly used in IoT applications. So it's going to follow not like it's a client server model. It's going to follow a publish subscribe communication model. Let us see what is that in the coming slides. So why we go for MQTT? It's mainly prescribed for low power devices and having a low bandwidth, low volume of data to be transferred, and it's mainly supports machine to machine communications, and it work efficiently also. That's the only reason that we go for MQTT. Its key features is it has a very lightweight s- header only, and QoS level, quality of service, is has three levels: 0, 1, 2, 3, and it is mainly suitable for low power battery devices, so that the battery will be for longer life. And it's an asynchronous model, publisher and subscriber model, and is standardized by the OASIS system. The main components of MQTT is publisher, which sends the data, and subscriber on the other end receives the data. In the middle, we have a broker. The right word is given as broker, central server that manages sending and receiving the data to a corresponding publisher and corresponding subscriber. Working principle, again, since the topic receives, the broker receives and filters the message. Filters in the sense here, the filter meaning that whoever subscribes only that particular relevant messages only will be passed on to the subscriber. Not all the published messages will be sent to the unsubscribed users. So that's the only main reason of the filter messages means. So there's no direct communication between publisher and subscriber. This is the classic graphical representation of this MQTT messaging techniques. The humidity temperature sensor is publishing that values through broker only. The broker acts as a central server, and it goes to give the different clients who were subscribed only. For those clients only it is going to give the value to that. So the value of the temperature and relative humidity will be published by the client. And see, the client itself has got two different meanings. Client is publisher, and again the client is again named as a subscriber. So client is divided into two different namings, publisher as well as subscriber. Whereas in the traditional model, you have client server model only. Here, central server is broker, central part, and client is divided into two different namings. One is publisher, one is client. Whoever client subscribed for this particular publisher only will get the information, but not all the clients. That's a message is important we want to convey to you. This is the another class example. MQTT clients example, you have sensors, temperature sensors, moisture sensors, and some accelerator value. So 30 is the temperature, degree centigrade is the temperature, 65% is the moisture, and 1.8 G is the accelerator value. So this value will not be, all the three values will be not passed on to the client. Whoever requests, see the pressure valve, that client only subscribed only for the value of the thing, and its temperature is given as a 30 only. And also cloud server was asking only subscribe to only the acceleration part. So the 1.8 value will be passed on to that particular client only. Whereas the moisture is left over because no one has subscribed to it. That's the reason it is not, even the value is published, it will be kept in the central MQTT broker server only, not passed on to any clients. Okay, hope you understand. And this is the generic explanation of what we have discussed. The most common broker available in the market is HAVMQ and Mosquitto. This is the naming predominantly used for common broker available in the market. And this is the message format, which wherein the variable header as well as a payload is optional, and there are some other flags are available: duplication flag, then retaining flag, then QoS header. We'll be discussing later on about this. And the remaining length of the message header is REM length. So these are the flags. Some of the flags is mentioned as part of this message format. And MQTT sessions between each client and server based on the server establishment ID, authentication ID, data exchange, and the session terminations. So per session it will be enabled, and after that session termination it will be vanished, the client ID. So this is the MQTT typical QoS level. QoS 0 level, left hand side, QoS 1 level, middle side, and right hand side QoS 2 level. The central part is MQTT server act as a broker, and publishers is the bottommost part. So between publisher and subscriber, the broker plays a major role based on what kind of level the QoS is being sent. The same level will be maintained. This is the QoS workflow. The same thing is again deposited when it will be used QoS level. When at most only once the message will be sent, no acknowledgement, no guarantee of delivery. The fastest method is also called fire and forget method. It's used only when occasional data loss is acceptable. Example, temperature updates every seconds. That's acceptable, for every second we are getting temperature data. 1 or 2 times if you don't get the data is lost means acceptable only. So at that time we can go for this QoS level 0. And QoS level is 1, at least once message delivered at least to once. Its message can be duplicated. It requires acknowledgement. It used when delivery is important. Okay, it's like register post. Okay. And duplications may be allowed. Sensor alarm notification. Example, sensor alarm notifications. The third one is QoS 2, exactly once. Message delivery is only once. It uses the four-step handshake model, highest reliability and more overhead and slower because it's a request 4-step handshake model. That's why it's have a more overhead and a slow in response. When it is used when duplication is not allowed. And example is financial transactions because money matters a lot. So in those critical transaction only, we go for this QoS level 2. The application, some of the applications of MQTT is smart home, smart grid, industrial SCADA, LT vehicle charging stations, IoT based energy management systems. In all those things, we go for MQTTs and smart cities like smart lighting and traffic monitoring systems. We go for MQTT. Advantages is it's very simple implementations and a very lightweight protocol, and it carries only very few data only, and it was going to work on very low power usage battery devices. And since it uses public and subscribe model, the network traffic will be very less. Disadvantages is nothing but when you go for QoS equal to 2 model, it increases the overhead. That's the main drawback of this one. And so far we have studied about this MQTT. Now we move on to COAP protocol. What is COAP protocols? Constrained Application Protocol. It's a lightweight web transfer protocol designed for constrained devices and IoT devices with limited resources. That is low memory, low power, low bandwidth. Constrained devices is nothing but very small devices, and it can use only very low power only. That's why it's called the constrained devices. And this particular protocol is now work only based on the UDP, not TCP protocol. It uses UDP protocol, user datagram protocol. It designed for low power, low bandwidth devices only. So COAP is often considered as a light version of the HTTP for IoT systems. COAP follows a client-server model similar to HTTP, but optimized for constraint base only. It is standardized by the Internet Engineering Task Force and work primarily over UDP, unlike HTTP, which uses TCP. So this is the one example of COAP, how it works. COAP, right hand side we have COAP environment, wherein you have a server, COAP server, and COAP client, and many other IoT devices. And the communication will be happening between the IoT devices and clients with the server, and device with the server. And the central server will be having one proxy server that communicates with the outside world, rest of the world. That's through HTTP communications. The blue color arrow mark bidirectional says HTTP communications with the rest of the world in the internet, wherein COAP environment will have a black color thick line bidirectional communications. It uses only COAP communications. That means UDP protocol. So again, it follows the client server model, means it has the generate request to servers, and servers in return transfers responses in the form of clients get, post, delete, and put message methods. Conformable and non-conformable tags for request and response messages. COAP has two similar data security models except that the data transfer takes place through UDP and not TLS. And the range of a COAP does not define physical range directly. Range depends upon underlying network, what it is having, either Wi-Fi or IEEE 802.15.4, that is ZigBee, or over cellular network. Based on this underlying network, the range differs. If there's a ZigBee, means It differs from 10 to 100 meters. Wi-Fi means 20 to 100 meters. And if it is cellular network means it spans over several kilometers. So what is the usage of CoIP means? Device to device communications, machine to machine communications, sensor data transmissions happens, and remote control of IoT devices happening. And the bottom table depicts the difference between the TCP and UDP. The main thing difference is TCP and UDP is connection oriented TCP is, whereas UDP is connection less, and also it TCP is reliable and UDP is unreliable, and TCP is slower and UDP is faster. So, and for suitable for real-time data is UDP. So wherever we need unreliable but fast communication and there's no connection-less environment, we go for this CoAP, constrained protocol. Constrained devices are electronic devices that have limited resources such as limited processing unit power, limited memory, RAM or ROM, and limited that was storages, hard disk, and limited battery power, and low bandwidth communications. So because of they operate under strict limitations like small computers, microcomputer, like 8-bit, 16-bit, or low end of 32-bit. And the RAM in will be very in low range only kilobits only. Battery operator for months or very few years only, and it's a low data rate. It works so over low data rate networks only. And class 0 and class 1 and class 2 are having the RAM as well as flash memories, and it is limited to very basics of IoT devices. Application of COFs, again it spans over the almost all areas, right from home and industry and healthcare, agriculture, even wireless sensor network also it has applications. Advantages is smaller header size, very faster, and it works on low power consumptions and it's very suitable for constrained IoT devices. This is the most advantages for the very constrained IoT devices. This CoAP is much more useful. Disadvantages: limited support in traditional web servers and less reliable. This is what the biggest disadvantage. And we end up with this session. And I have followed these references from as well as textbooks also. Thank you.